There are several key differences between lighting contactors and motor contactors. Primarily, we will consider current rating, arc interrupting capability, and electrical life. Lighting contactors are typically rated for higher current than motor contactors. This is because lighting loads can have high inrush currents when turned on. Lighting contactors also have a higher arc interrupting capability than motor contactors. This is because the arcing caused by switching lighting loads can be more severe. Lighting contactors are designed for a shorter electrical life than motor contactors. This is because lighting loads are typically switched more frequently than motor loads. Other considerations include contacts, coil voltage, mounting, and safety standards. Lighting contactors often have silver cadmium oxide contacts, which have better arc quenching properties. Lighting contactors may have different coil voltage options than motor contactors. Lighting contactors may have different mounting options or accessories for easier installation. Lighting contactors may need to meet specific safety standards for lighting applications, such as Underwriters Laboratories 943. The high price of lighting contactors is due to the following factors. Firstly, high current rating. Secondly, higher arc interrupting capability. Thirdly, shorter electrical life. Fourthly, specialized design for lighting applications. And fifthly, meeting specific safety standards. Consider the Allen Bradley 100 C23D10. This is a 3-pole 25 amps motor contactor rated for 480 volts alternating current. The Allen Bradley 100 LC20 ND4 is a 3-pole 20 amps lighting contactor rated for 480 volts alternating current. As you can see, the lighting contactor has a higher current rating and is designed specifically for lighting applications, which accounts for the higher price. In more detail, let's discuss the current rating. The current rating of a contactor is the maximum amount of current that it can safely switch. Lighting contactors are typically rated for higher current than motor contactors because lighting loads can have high inrush currents when they are turned on. An inrush current is a surge of current that occurs when an electrical device is first turned on. Lighting loads, such as incandescent lamps and fluorescent lamps, can have very high inrush currents. This is because the resistance of the lamp is very low when it is cold. As the lamp heats up, its resistance increases and the current decreases. Motor contactors are typically rated for the running current of the motor. The running current of a motor is the amount of current that the motor draws when it is running at its rated speed and load. The running current of a motor is typically much lower than the inrush current of a lighting load. Next, let's consider the arc interrupting capability. The arc interrupting capability of a contactor is its ability to safely interrupt an electrical arc. An electrical arc is a flow of current through the air between two conductors. Arcs can occur where a contactor is opened or closed. Lighting contactors have a higher arc interrupting capability than motor contactors because the arcing caused by switching lighting loads can be more severe. This is because lighting loads can have high inrush currents, which can create a large arc when the contactor is opened. In addition, lighting loads are often switched more frequently than motor loads, which can also increase the severity of the arcing. Motor contactors are typically designed to interrupt the arc caused by the motor's starting current. The motor's starting current is the amount of current that the motor draws when it is first started. The motor's starting current is typically higher than the motor's running current. Now let's consider the electrical life. The electrical life of a contactor is the number of times that it can safely switch a load. Lighting contactors are designed for a shorter electrical life than motor contactors because lighting loads are typically switched more frequently than motor loads. Lighting loads, such as incandescent lamps and fluorescent lamps, are often switched on and off several times a day. This can put a strain on the contactor's contacts and cause them to wear out more quickly. Motor contactors are typically designed for a longer electrical life because motor loads are typically switched less frequently than lighting loads. Motor loads, such as pumps and fans, are often run continuously for long periods of time. This puts less strain on the contactor's contacts and allows them to last longer. Regarding contacts, lighting contactors often have silver cadmium oxide contacts, which have better arc quenching properties. Silver cadmium oxide is a material that is very effective at quenching electrical arcs. When an arc occurs, the silver cadmium oxide contacts will vaporize and absorb the energy of the arc. This helps to prevent the arc from damaging the contactor's contacts. Motor contactors typically have copper contacts. Copper is a good conductor of electricity, but it is not as effective at quenching arcs as silver cadmium oxide. Regarding coil voltage, lighting contactors may have different coil voltage options than motor contactors. The coil voltage of a contactor is the voltage that is required to energize the contactor's coil. The coil is an electromagnet that is used to open and close the contactor's contacts. Lighting contactors may have different coil voltage options than motor contactors in order to accommodate the different voltage requirements of lighting systems. For example, some lighting systems use 277 volts alternating current, while others use 120 volts alternating current. Motor contactors are typically available with a variety of coil voltage options to accommodate the different voltage requirements of motor systems. Regarding mounting, lighting contactors may have different mounting options or accessories for easier installation. Lighting contactors are often mounted in electrical panels or enclosures. They may be mounted on a DIN rail or on a back panel. Motor contactors are also typically mounted in electrical panels or enclosures. They may be mounted on a DIN rail or on a back panel. However, motor contactors may also be mounted directly to the motor. Regarding safety standards, lighting contactors may need to meet specific safety standards for lighting applications such as Underwriters Laboratories 943. Underwriters Laboratories 943 is a safety standard for lighting contactors that are used in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire. Lighting contactors that are used in hazardous locations must be designed to prevent the ignition of flammable materials. Motor contactors must also meet certain safety standards. These standards vary depending on the application. The National Electrical Code, or NEC, covers motor circuits in Article 430. This article provides detailed requirements for motor circuit conductors, overload protection, and disconnecting means to ensure safety and proper operation. The higher price of lighting contactors is due to several factors. Firstly, they have a high current rating. Secondly, they have higher arc interrupting capability. Thirdly, they have a shorter electrical life. Fourthly, they have a specialized design for lighting applications. And fifthly, they meet specific safety standards. The specific examples we can consider are the Allen Bradley 100 C23D10 and the Allen Bradley 100 LC20ND4. The Allen Bradley 100 C23D10 is a 3-pole, 25 amps motor contactor rated for 480 volts alternating current. The Allen Bradley 100 LC20ND4 is a 3-pole, 20 amps lighting contactor rated for 480 volts alternating current. As you can see, the lighting contactor has a higher current rating and is designed specifically for lighting applications, which accounts for the higher price. Let's elaborate on arc interruption in more detail. Arc interruption is critical in both lighting and motor contactors, but the demands differ. In lighting, especially with older technologies like fluorescent lamps and even some LED drivers, the initial inrush current can be significant. This inrush creates a substantial arc when the contacts open, demanding robust arc suppression. Lighting contactors often employ features like silver cadmium oxide contacts, as previously mentioned, or other specialized materials and designs to quickly extinguish these arcs. This is essential to prevent contact damage and ensure long-term reliability. In motor control, the arc interruption challenge is different. While inrush current is also a factor, the inductive nature of motor loads creates a sustained arc when the contactor opens. This arc is due to the energy stored in the motor's magnetic field. Motor contactors are designed to handle this sustained arc, often using arc chutes or other methods to break the arc into smaller, less damaging components. The design of the arc chute and the materials used are crucial for efficient arc interruption. Also, consider the contact materials and design. The choice of contact materials significantly affects the performance and lifespan of a contactor. Silver cadmium oxide, as used in some lighting contactors, offers excellent arc-quenching properties. However, cadmium is increasingly restricted due to environmental concerns, leading to the development of alternative materials. These alternatives must provide comparable arc quenching while meeting environmental regulations. Motor contactors typically use copper alloy contacts, often with a silver plating to improve conductivity and reduce contact resistance. The contact design, including the shape and pressure, also plays a crucial role in ensuring reliable contact and minimizing contact wear. Another key aspect involves the coil characteristics. The coil is the electromagnetic component that actuates the contactor. The coil voltage and current requirements must be compatible with the control circuit. Lighting contactors and motor contactors may have different coil voltage options to suit various applications. Furthermore, the coil's inrush and sealed current characteristics are important. The inrush current is the current drawn by the coil when it is initially energized, while the sealed current is the current drawn by the coil when it is held in the energized state. Efficient coil design minimizes energy consumption and reduces heat generation. Thermal considerations are also important. Contactors generate heat due to current flow through the contacts in the coil. Excessive heat can damage the contactor and reduce its lifespan. Therefore, proper ventilation and cooling are essential, especially in high current applications or enclosed environments. The contactor's thermal rating indicates its ability to dissipate heat without exceeding its temperature limits. Contactors used in high temperature environments require special consideration to ensure reliable operation. Regarding standards and certifications, contactors must comply with relevant industry standards and certifications to ensure safety and performance. These standards specify requirements for various aspects of contactor design, testing, and application. Examples of relevant standards include Underwriters Laboratories, or International Electrotechnical Commission, or IC, and Canadian Standards Association, or CSA, standards. Compliance with these standards is essential for ensuring that contactors meet safety requirements and perform reliably in their intended applications. As related to wiring and terminations, the contactor's terminals must be properly sized and rated for the expected current and voltage levels. Proper wiring practices are essential to ensure reliable connections and prevent overheating. Terminals should be torqued to the manufacturer's specifications to ensure a secure connection. The use of appropriate wire connectors and lugs is also important. Also, consider the application-specific requirements. The choice of contactor depends on the specific application. Factors to consider include the type of load being switched, the operating voltage and current, the switching frequency, and the environmental conditions. Lighting contactors are specifically designed for switching lighting loads, while motor contactors are designed for controlling motors. Using the wrong type of contactor can lead to premature failure or unsafe operation. You should also consider the interrupting rating, which is the maximum current that a contactor can safely interrupt under specified conditions. The interrupting rating must be sufficient to handle the fault current that could occur in the circuit. Using a contactor with an inadequate interrupting rating can result in catastrophic failure and pose a safety hazard. There are different types of contactors. Firstly, electromechanical contactors are the most common type of contactor. They use an electromagnet to close the contacts. Secondly, solid-state contactors use semiconductor devices to switch the load. Solid-state contactors offer advantages such as faster switching speeds, longer lifespan, and quieter operation. Thirdly, definite-purpose contactors are designed for specific applications such as heating, ventilation, and air conditioning or HVAC systems. They are typically less expensive than general-purpose contactors. When it comes to installation and maintenance, proper installation and maintenance are essential for ensuring the reliable operation of contactors. Contactors should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. Regular inspection and maintenance can help to identify potential problems before they lead to failure. Contactors should be kept clean and free of dirt and debris. Contacts should be inspected for wear and damage. Loose connections should be tightened. Also, consider the future trends in contactor technology. Contactor technology is constantly evolving. Some of the current trends include the development of more compact and energy-efficient contactors. The integration of smart features such as remote monitoring and control is becoming increasingly common. The use of new materials and designs is leading to improved performance and reliability. Before finishing up, let's return to the contactor examples. The Allen-Bradley 100C23D10 motor contactor typically features screw terminals for easy wiring, a compact design for installation in tight spaces, and is often part of a motor starter assembly. Its electrical life is rated for a specific number of operations under load, and it's designed to handle the inertia and running currents of small motors. The Allen-Bradley 100LC20ND4 lighting contactor often includes features tailored for lighting control, such as options for panel mounting or integration with lighting control systems. It is built to withstand frequent switching cycles typical of lighting applications and may have additional surge suppression components to protect against voltage spikes. The price difference between these two, despite similar amperage ratings, reflects the internal design differences and specialized features that cater to their respective applications.